multi-WAN router support for failover or load balancer. This support for multiple WAN connections enables pfSense to load balance or failover traffic from a LAN to multiple internet connections. With load balancing, traffic from the LAN is shared out on a connection-based, round-robin basis across the available WANs. With failover, traffic will go out to the highest priority WAN until it goes down, then the next is used. pfSense monitors each WAN connection using either the gateway IP or an alternate monitor IP address, and if the monitor fails, it will remove that WAN from use. This also reduces latency to users. Load balancing can be implemented with hardware, software, or a combination of both. Port forwarding / NAT, or network address translation. You can also use pfSense to forward ports or network addresses translation. Network address translation, NAT, is the process where a network device, usually a firewall, assigns a public address to a computer or group of computers inside a private network. The main use of NAT is to limit the number of public IP addresses an organization or company must use for both economy and security purposes. NAT helps improve security and decrease the number of IP addresses an organization needs. NAT gateways sit between the two networks, the inside network and the outside network. Systems on the inside network are typically assigned IP addresses that cannot be routed to external networks. Okay, now let's discuss the pfSense features through a use case diagram. This diagram will give you an idea of how pfSense plays a vital role in a network. The router ISP modem connects pfSense to the internet. The switch connects pfSense to various desktops. In this scenario, pfSense acts as a DHCP server, firewall, a NAT device. It can play these roles distinctly or all at the same time simultaneously. Let's explore some other standard features of pfSense. DHCP Relay Agent feature serves the DHCP service for all clients. The firewall feature filters requests and responses by source and destination IPs, source and destination ports. It also limits simultaneous connections on per rules basis. NAT port forwards includes range and use of multiple public IPs, one-to-one NAT for individual IP or multiple subnets. The multi-WAN functionality enables the use of multiple internet connections with load balancing and failover and usage distribution. With this, you can achieve redundancy across multiple ISP connections. And not only that, you can distribute the traffic from your internal network to the internet to numerous links in a load-balanced fashion. As a VPN server, pfSense offers two options for VPN connectivity. IPsec allows connectivity with any device supporting standard IPsec. This is most commonly used for site-to-site connectivity to other pfSense installations and almost all other firewall solutions, Cisco, Juniper, etc. It can also be used for mobile client connectivity. The second option is OpenVPN. OpenVPN is a flexible, powerful SSL VPN solution supporting a wide range of client operating systems. Let's assume the computers are in different sites. You can use IPsec VPN to connect them both together. Now that you're familiar with pfSense, let's go ahead with installation and configuration of pfSense. But before we start with that, let's review the minimum hardware requirements for installing and running pfSense. At the time of recording this course, the latest version of pfSense is 2.x. pfSense is an open source software and occasionally releases new versions or patches. So to review the latest requirements, you should always refer to the latest documentation. So let's review it now. Navigate to the pfSense site requirements page at pfSense.org/hardware. Okay, here we are. This page lists some ready-made appliances which are tried and tested by the pfSense community. If you want to avoid the hassle of building your server and trying out all the components, then it is recommended you purchase one of these appliances. But of course, if you are like a tinkerer or a geek, then you can opt for this option to build your server. Let's review the hardware requirements for building your own server. As you can see, the minimum requirements as of the latest version are very modest. pfSense can run on a PC with 500 MHz CPU and 256 MB of RAM. Do you know of any sophisticated software which is capable of running on these low specs? Anyway, the recommended requirements are a bit higher than these. But still, 1 GHz CPU and 1 GB of RAM is still very modest by modern standards. Here are some additional details for specific components of the system. You can check the compatibility of your network interface cards here as well. This is very important because pfSense is a firewall and its primary function is securing your network. Besides that, there is also a link to the compatibility list for FreeBSD. As mentioned earlier, pfSense is based on FreeBSD, so it'll make sense to check the compatibility of your hardware with FreeBSD compatibility list as well.